In this video we will discuss about the various dimensionality reduction algorithms in machine learning. Dimensionality reduction methods aim to minimize the number of input variables in a dataset. As the number of features increases, it increases the possibility of overfitting. It is the process of reducing the number of variables under consideration by obtaining a smaller set of principal variables. Advantages of dimensionality reduction algorithms are it requires less space to storing the data and it reduces the computation time since features are reduced. It reduces the number of variables by eliminating redundant dataset. It reduces the complexity of the algorithm, thereby it reduces cost. Simple models can be chosen with reduced dataset. The disadvantages of dimensionality reduction are there may be loss of information and sometimes principal components are unknown. There are two types of dimensionality reduction techniques. The first one is feature selection. This involves to identify a subset of the original features in an attempt to find a smaller subset which we can be used to model the problem. The types of feature selection methods are filter, wrapped and embedded. Second is feature extraction. Feature extraction involves reducing the original set of raw data into manageable groups for the purpose of processing. It is carried out most often with text and image data, and the most important features are extracted and processed, instead of processing the entire dataset. The following are the various dimensionality reduction approaches. Let us discuss in brief one by one. Principal components analysis is an unsupervised learning class of statistical techniques used to explain data in high dimension using smaller number of variables called the principal components. PCA is explained in detail and it is available in this channel. LDA is similar to PCA in which it minimizes the variance within the individual class and maximizes the distance between means of two classes. LDA is explained in detail and it is available in this channel. GDA is an extension of LDA to nonlinear distribution, since conventional LDA is not suitable for nonlinear datasets. GDA deals with nonlinear discriminant analysis using kernel function operator. GDA concepts in detail is also available in this channel. Factor analysis is a linear statistical model. It reduces the huge number of variables into a few numbers of factors. Factor analysis is available in this channel in detail. In subset selection, the smaller subsets of features are chosen from a set of many dimensional data to represent the model by filtering, wrapping, embedding. It is also known as variable selection, attribute selection, feature selection. The autoencoder, a form of an artificial neural network, is a prominent technique for dimensionality reduction. Its primary goal is to replicate the input to the results. This process compresses the input into a latent space before utilizing that representation to produce the output. A random forest is a supervised machine learning algorithm that is constructed from decision tree algorithms. It is used to solve regression and classification problems. It utilizes ensemble learning, which is a technique that combines many classifiers to provide solutions to complex problems. There is no optimal method for dimensionality reduction, as well as no technique to problem mapping. Therefore, the ideal strategy is to conduct systematic, well-controlled trials to determine which dimensionality reduction methods to produce the greatest results on your data. Thank you for watching this video. If you like this video, subscribe this channel and press the bell button.